Once we've built our solution, we can actually do much more in-depth analysis too and look at different scenarios. We have our general solution, and what we can do is propose scenarios now. If R equals 3, so this again was our flow rate in liters per minute of the water. So if we fix that, we can then ask ourselves, well, what is it going to take to get to certain concentrations? So we're told that we're going to pick R equals 3, and we're going to have our Q naught is equal to twice QL. So in other words, we start at twice the salt amount as the long-term level. And again, we should have some intuition about this. This system is fairly straightforward. So if we imagine plotting Q against time, we know in the long run we should end up at 25 kilograms. What we're going to do is start at 50 instead, and what we'd expect to have happen is some kind of decay towards that level of 25 kilograms if we start at 50. We're going to be flushing out the super dirty water with the water at 0.25 kilograms per liter and heading towards this balance value here of 25. But how do we actually work that through in the math? Well, we can use all the initial conditions and the R equals 3 to solve for C and some other properties. So let's plug those values in. R equals 3 means that our Q is 25 plus C e to the minus 3 over 100 T. If our Q naught is 2 times QL, but QL we know is 25, so we're going to have 2 times 25, that's going to be 50. What we can then do is use that to find C. And so our Q, which is 25 plus C e to the minus 3 over 100, what we're going to do now is set T equal to 0. Our Q naught is our salt level at T equals 0. And we can plug in the salt level of 50 kilograms. And that gives us a nice equation for C. 50 equals 25 plus C times e to the 0. Oh, that's not so bad. We're going to get 50 minus 25 equals C. C is also equal then to 25. So our solution now is going to be 25 plus 25 times this exponential. That's now our particular solution. And that would describe this curve here, where we start at 50 kilograms of salt in the tank and gradually water it down until it reaches the 25 kilograms. What we're interested though is in a more particular point, finding the time after which the salt level reaches some threshold. So within 2%, plus or minus, well, we know it's going to be plus, that's the level it's going to hit first. And if we're adding 2%, then that'll be 2% of 25, that'll be 0.05. So the level there will be 25.5 kilograms. What we can do with our Q value here, or our Q formula here, is set it up and solve for that time. We now have the formula for the graph. We want to find the time where that reaches 25.5. There's our solution. We're going to set it equal to the slightly higher value, 25.5, and start solving for T. We want to know when that event occurs, so let's track that down. We've got the 25 and the 25.5. We'll bring that over first. That'll give us 0.5 on the right-hand side. We can divide through by 25. And that's going to give us e to the negative 3 over 100 t equals 0.02. We want to solve for the t. The only way to get into that is to take the ln of both sides. So we'll get negative 3 over 100 t is ln of 0.02. And t then is negative 100 over 3 ln of 0.02, which is approximately 130. And the units of time we had were minutes. and that's to get Q within 2% of QL, which was our 25 kilogram baseline level. So we can sketch this out. Our graph of T, here's 25, here's our starting value. What we've just found is that this curve is going to drop. It's going to get closer and closer to 25, but it's going to reach 25.5 at about 130 minutes in terms of the time from the start to when we reach that threshold. An interesting follow-up question would be, find the flow rate that is required if the value t is not to exceed 45 minutes. So we've just found 130 minutes, and how could we increase the value of r, which shows up, be careful here, this is our r value here. Could we change that so that instead of taking 130 minutes, we had a curve that went down faster and took 45 minutes to reach that same threshold? We'll include that as one of the practice problems for this week.